Hey guys, this is Julio with Aircon Academy. I just wanted to touch bases on this heating chart that I use in class a lot of times. And I wanted to just explain that, we have a heating chart that kind of looks like this. Here, what we're going to do is we're going to heat up, let's say, the water. Let's just talk about water. So then we're going to come across like this, and we're going to boil the water off. We're going to evaporate the water. Then we're going to come up like this, and we're going to raise the temperature. Here we have 100%. There's going to be 100% liquid right here. This other side, we're going to have 100% vapor right there, 100% vapor. Then what we can do is we can raise the temperature of this vapor above this temperature right here. Well, this temperature is going to vary. That can vary because of the pressure. So now we call this my saturation temperature. In the saturation temperature, what we're doing is we're changing the state. Here we're adding heat coming this way and going up this way. Then after we do that, then we're going to drop the temperature like this. Once we drop the temperature, we drop it down to saturation temperature. Then we're coming back this way like this. So now we're going to go from 100% vapor down to 100% liquid. So in other words, what we're doing is we are condensing, the, let's say, refrigerant. Then we come down like this, and again, we lower the temperature below the saturation temperature. So on here, we have these terms that we have to remember. Here, what we're doing is we are evaporating. We're changing it from liquid to vapor. So this is what they call latent heat of vaporization. Latent heat of vaporization. Here, we're raising the temperature above the saturation temperature. So now we are what they call superheating. We come back down. Because we're come back down, now what we're doing is we are de-superheating right here. We're lowering the temperature down to condensing temperature. Now we come from 100% vapor to 100% liquid. And what we do is we are subcooling right here. So here we evaporated, we superheated, de-superheat, we condense, and then we subcool. Those are very, very important terms that we need to remember when we're dealing with air conditioning or refrigeration. Now, this chart, we talked about this chart before, but one of the things I wanted to point out is that the refrigeration cycle. Well, one of the things is that we have the refrigeration cycle like this. First, we have our compressor. The compressor is going to compress the refrigerant. It takes that low pressure superheated vapor that's coming in, and it compresses it, and it comes out as high pressure superheated vapor. Goes out into the condenser. From the condenser, it goes to the metering device. So we have the condenser here. There's my metering device. And then from here, we go on over to the evaporator. Yeah, we got to have the four components. It doesn't matter if you have a chiller, a window unit, a split system, a rooftop, package unit, it doesn't matter. We have to have the compressor, condenser, metering device, and evaporator. Okay, the compressor is going to draw the refrigerant in. So now we are lowering the pressure on this side, raising it on this side. Okay, so that's why it comes out as high pressure superheated vapor, and that's why it comes in as low pressure superheated vapor. When it comes out of the compressor, in the condenser, what we're going to do, first we're going to de-superheat, then we're going to condense, and then we're going to subcool right here. We go through the liquid line and come in through the metering device as 100% liquid. The metering device creates a pressure drop right there. Goes into the evaporator. The evaporator, the refrigerant is going to be 75% liquid, 25% vapor. As it travels through, the percentages change. So here we have 75-25. Here we have 70-30. Here we have, let's say, I don't know, 50-50. Here we have 30-70, meaning 30% liquid, 70% vapor. Here we had 70% liquid, 30% vapor. Here we have, let's say 10, 90. 10, 90, 10% liquid, 90% vapor. Here's going to be 199. Now, 1% liquid, 99% vapor. Right here at this point is what I like to call my predetermined point. The engineer designed it so that that's the last little drop, poof, last drop of liquid, it just disappears. That liquid disappears, and then from here, what are we doing? Well, we're raising the temperature above the saturation temperature. Well, what is the saturation temperature? The saturation temperature in the evaporator, we want it to be about 40 degrees. All air conditioning evaporators, regardless of the type of refrigerant, we want it to be right around 40 degrees. So from here all the way to my predetermined point is going to be 40 degrees. Temperature from there is going to go up. It's going to go up because now we're superheating the refrigerant. Let's say that here we take the temperature and it happens to be, I don't know, let's say 60 degrees Fahrenheit. Goes into the compressor at 60. Well, when it comes out at about 200 degrees right there. We lower the temperature all the way to the condensing temperature. And that condensing temperature, let's just say, for example, it's going to be 120 right here. Then we start to subcool, comes into the metering device, and we want the liquid line to be approximately 100 degrees. So we want this to be about 100 degrees Fahrenheit right there. Now, like I tell everybody in class, I'm telling you this is 40 degrees. Well, I don't want you to believe a thing I tell you. I want you to look it up. Don't believe what people tell you. Don't believe what you hear. Always find out for yourself what the truth is. I'm telling you that's 40. So in other words, you're not going to believe me. You're going to say, okay, no, we need to test it. We need to verify this. So to verify it, what we do is we hook up my blue gauge, my suction line gauge, my blue gauge onto the suction line. And let's say that this is R22. So we're going to get 68 psig. If this happened to be, let's say, 410A, then we're looking at a temperature a pressure of about 118 psi. Regardless of how you look at it, whether it's the 410A with 118 or the 68 for R22, this is going to equal 40 degrees. So we look at the PT chart. PT chart's never going to lie to you. We look at the PT chart, we see that it's 40 degrees. So now we verified that my evaporator's at 40. And remember, if it's air conditioning, typically we're going to want my evaporator to be about 40 degrees. Now, we have to do the same thing on the high side. So we hooked up the blue gauge here. Now what we're going to do is we're going to hook up my red gauge right there. This red gauge, if it's R22, is going to read 260. Let's say that it's not R22. Let's say that it's 410A. Then it's going to read about 400. Let me see, I'm running out of room here. It's going to be about 419 psig. Whether it's 260 or 419, this is going to equal 120 degrees. 120 degrees Fahrenheit. That means that my saturation temperature is going to be 120. When I take my temperature up here is 100 degrees Fahrenheit. Okay, so now let's put all of this together. What we have here is when it leaves the compressor, it's going to leave, we said, about 200 degrees. So it's leaving the compressor right here at about 200 degrees. We said that the first thing we're going to do, or the first thing the condenser is going to do, is going to desuperheat. So we're going to lower the temperature down to saturation temperature. We lower this down to this point. The saturation temperature, we said it was 120. Okay, why is this 120 degrees? Well, because the pressure, when we looked it up in the PT chart, cross-referenced to 120. If this is, like we said, if it's the 410A, my pressure is going to be 419 pounds of pressure, which is going to equal 120. So regardless, yeah, we're going to have that saturation temperature there. As the outside air temperature changes, this pressure is going to drop. If the outside air temperature drops, this comes down. If the outside air temperature goes up, this comes up. So this temperature here is going to fluctuate, or this pressure here is going to fluctuate changing the temperature. So this is just an example that I have here. So after we desuperheat, bring the temperature from 200 down to 120, we condense. Condense, condense, condense. Well, when we're condensing, we basically have 3 lines right here. On this one here, we're going to be, well, this is 100% liquid. Here is going to be 75% liquid and is going to be 25% vapor. This one here is going to be 50, 50, 50% liquid, 50% vapor right there. This one here is going to be 25, 75, 25% liquid, 75% vapor. And right here, right there, we're going to be at 199. 1% liquid, 99% vapor. After that little line right there, we're at 100% vapor. In other words, this line right here, this happens to be my, what I like to call my predetermined point, which is this one here. And then we raise the temperature all of the way up to 60 degrees. So now, once it's at 60 degrees, we're coming into the compressor. Once the compressor compresses it, it takes all of this gas, all of this heat that we absorbed in the evaporator from the return air temperature, because we have all of this heat that we absorbed, because we have 75 coming in, 55 going out. So we have 75 return air temperature, 55 supply air temperature. That's what's going out. We absorb all of that heat, send it to the refrigerant. The refrigerant comes to the compressor compresses it. Because of that, the temperature goes from 60 all the way up to 200 degrees. It goes from 60 to 200 degrees. Then we desuperheat right here. We get it down to saturation temperature. Then we start to condense. We get a little tiny drop of liquid there, and then we add more and more liquid until we're at 25% liquid, 50% liquid, 75% liquid, 100% liquid. Once we have done that, then we can start to subcool. Once we subcool, we're going to be here at 100 degrees Fahrenheit. We're at 100 degrees Fahrenheit and in the liquid line. So this is my liquid line right here. This is basically my liquid line, part of my liquid line right here. The refrigerant, what it's going to do now as it goes into the metering device. This is a little tricky because here we're at 100 degrees right here. From here, it jumps all the way up to right here. 75% liquid, 25% vapor right there. So we're here, and then it jumps all the way to here, 75, 25. Because 25% of it becomes gas, becomes vapor, we have what they call flash gas. That flash gas is what makes the temperature drop. We drop that temperature, now we're at 40 degrees. Now, looking at a metering device, it's coming in at 100 degrees, and then in a space about that big, maybe about an inch or two, it's going to go from 100 down to 40 degrees because of the flash gas. We go into the evaporator. We evaporate it, so we're adding latent heat of vaporization. After all of that refrigerant has boiled off and we're at 100% vapor, then we start to superheat. We superheat it from the predetermined point, which is right here, all the way up to the compressor. The compressor compresses it, comes out of the compressor at 200 degrees. So it jumps basically from here to here, and it comes out at 200 degrees. Once it comes out at 200 degrees, we desuperheat. So we lower the temperature down to 120. We condense it at 120 degrees. That's our saturation temperature. And then once we're here, we start to subcool. We subcool to 100 degrees. Then it jumps at the metering device to 75, 25. All of that flash gas instantly flashes off, temperature drops, and the whole cycle starts over again. I wanted to explain this heat chart right here and the refrigeration cycle, so it's easier for some people to understand what is happening at the system, in the refrigeration system, and what happens here in this chart. So the terms, we are adding latent heat of vaporization, then we superheat. When we superheat, we're raising the temperature above the saturation temperature. In this example, the saturation temperature happens to be 40 degrees Fahrenheit. How do we know it's 40 degrees Fahrenheit? Because we took this pressure. We got the saturation temperature. We take the actual temperature reading here, we know that it's coming out at 60. So that means that we have 60 degrees coming here, coming into my compressor, minus the 40. That gives me 20 degrees of superheat. If I was to take my temperature reading over here someplace, then I would read 50. In other words, I would have 50 minus 40, and I would end up with 10 degrees of superheat. If I took it further down, that temperature would be higher. So now we're adding more and more superheat. On my high side, we desuperheat right here. We start off at 200, and we finish at 120. Because we do that, when we subtract, we have a total of 80 degrees of desuperheating. Now, typically, we don't worry about the desuperheating, but on this other one here, we start off at 120. We finish at 120. So we do not change the temperature at all. The temperature while it's condensing, we don't change it at all. Starts at 120, we finish at 120. Then at the end, we start off at 120 because right here is 120 degrees. Right here is 120 degrees. We end at 100 degrees. Here we end at 100 degrees. So now we subtract, we end up with 20 degrees of subcooling. We end up with 20 degrees of subcooling right here. So here we have 20 degrees of subcooling. That shows you how to get your superheat readings up here on top, how to get your subcooling readings. And I'm hoping that this kind of explains, what is happening in the refrigeration system, the superheating, the desuperheating, and the subcooling. One real quick question. Why do we want to have superheat? Well, if we have superheat, we know we're not going to get liquid back to the compressor. Inside the compressor, we're going to have oil here. If liquid comes back to the compressor, we are going to destroy that compressor. So we don't want that to happen. To stop that from happening, we have to have superheat. If we have 2 or 3 degrees of superheat, then that's perfect. That's great. The problem is that then this predetermined point is going to be too close to the compressor. We don't want it too close to the compressor because if something goes wrong, we'll get liquid back. So we want it up here. The manufacturer is going to tell you. The manufacturer is going to say, we want 6 degrees of superheat, 10 degrees of superheat, 5 degrees, whatever the manufacturer says, that's what you go by. In class, typically we say, 8 to 12. So I usually use 10 degrees of superheat in class because that's rule of thumb. But who knows better, me or the manufacturer? The manufacturer knows better. So we look to see what the installation manual says so we can see what our superheat should be. Also, we can look on the panels to see if there are charging charts to see what our superheat should be. The same thing with the subcooling. With the subcooling here, I have 20 degrees of subcooling. Well, rule of thumb says, okay, that's pretty good. That's, that's about right. But, who knows better, the manufacturer or me? The manufacturer may say we want 10 degrees of subcooling, 5 degrees of subcooling, 25 degrees of subcooling. The manufacturer knows better. Look in the charging charts, look in the unit, and see what the manufacturer says. Again, hopefully this helped you understand what is happening in the system to what's going on with this chart. Superheating, raising the temperature above the saturation temperature. Desuperheating, lowering the temperature down to saturation temperature. Subcooling, lowering the temperature below the saturation temperature. I hope this helped. This is Julio, Aircon Academy, and be careful out there.